Next, second. Yeah, I think second one. Yeah.
All right, let's get started. Hello, everybody. Good morning. Thanks for coming. So this is sort of what we call a community-driven conference experience. We have around 8 meetup groups coming together for this particular event. So thanks for joining us today. So we'll get started. The first one is an introduction to microservices by Manu from Schneider Electric. Manu?
Yeah. Thank you. Good morning, everybody. Thank you for joining so early. Good morning. Welcome. My name is Manu. I work at Schneider Electric. I work as an engineer at Schneider. So we're going to discuss a little introduction about microservices. So this is a short introduction to 15 minutes. So I'll try to see how I can build concept of microservices to you. Right. So before we start, I'd like to build an application. So this is a scratch brand product we're okay. So what is image from the net? So you can see what we're trying to do. So let's say that I have a kind of e-commerce product where you order the product from your mobile and try to pay and can you tell me what technologies or what stacks you use to build this kind of a product? Let's say you're a startup, you don't have a lot of capital to invest, so you are trying to do minimum resources. Okay. Anything else? Any lambda? You go with the lambda. I don't want servers. Okay. Right. So there are multiple choices that you can think of, right? And very conservative people who are more concerned about transaction analytics like that, they may want to use relational database. Nowadays, if you want to say that, but some people may go like that. So what happened? You got the application of the product and it becomes a big in the market. Then suddenly the expectation from the market and from your stakeholders is increasing. So there is a lot of demand for you to build add on more and more features into that particular product, right? So you need more analytics. You want to study the user behavior. You want to keep track of orders. You do not want people to do their orders. You want to keep the cart accurate, right? So at this point, you see that there are a lot of requirements that are coming in that you want to do. And many times, what happens is the requirement itself can be, actually in multiple directions. For example, the marketing may come, okay, we need to go for a sale one day, which means that the heat or scalability has to be really high, right? But all that may not really result in the orders. So if you see that one application that you have created, now people ask it to behave in a multiple directions, right? Certain sections you want to certain sections want to expand drastically, whereas certain sections it's okay to don't have that kind of scalability, right? So at this situation, what you can do? What type of changes you can bring to your architecture? So you got the point, right? Initially, you have like one application that you built with a mean stack or a serverless. So now you have different needs. So what you can do to kind of support the business with that need, right? So one of the approaches that that you kind of split the application into multiple applications, right? Depending on the business case and the technology stack that you choose. Right? So when you have a kind of searching of the products, you may use a MongoDB for to solve the product. Then that may be a mean stack or not backend, right? Or where you have a card, you can use an in-memory system like a Redis database. So different sections of the application you can go with a different architecture, and you can have all those these applications as different different products, different applications, but they talk to each other based on some services. You see this? It works. Any comments? Yeah, we support everything. Okay, so this is an example how you can kind of split an application. So I'm not going to cover microservices, but this is what typically you think about in real world, right? So more or less, this is the practice generally. So they have one application and now you have different needs, right? So coming to the microservices, to give an introduction. So the first thing the microservices community did actually to give awareness for microservices is to name the structure what we have now. So the good name they come up with is a monolith, right? So because if until we do not have a name for the current one, it's really hard to define what is new. So what we had before was a monolith application, or eventually all applications that you develop, and it's very easier to do. You have one code base, so you have a simple package deployment for all of your application, and so instead that you have components and other stuff, there is no problem, right? So and after that, what we have seen with the growing demand in business, you have more complexity in functionality. You have a lot of scaling needs. You have need to do the fault tolerance, which means that when I'm searching for a product, even if it's not giving result, it's okay to do a search again. But when you're ordering a product, if the ordering page you want to really support the user start from there, right? Because that is a growing business case. So that kind of governance you want to build in. So there are a lot of definitions for microservices around what the characteristics. So which one I like? So this is by Aaron Gupta. So what it says is that the growing demand for agility, flexibility, and scalability to meet rapidly evolving business needs create a strong need for faster and more efficient delivery of software. Right. So if you look at the definition of what it is, focuses on the delivery of the software, right? It's not really how you create one particular piece of software. So a lot of, let's say architecture is really a broad concept. So microservices focus on the delivery of the software. So how you package and deploy the application, not really how you create that particular piece. That's what the focus of microservices. Right? So coming back to the earlier example, more of a theoretical way, if you see, so it's an approach developing simple application as a simple small set of collaborative services. So initially we had one application with different components grouped into the same application boundary. So the team did a good job in separate components. There is no problem in the design of the application itself. But the problem was that even though how the design was, different sections has to behave differently. There is a lot of need which is different to each other. So that is where we have moved to a new structure where there is a separate application boundary for different services. Like the order management has a completely different responsibility, how you want to implement, how you want to do the scalability part. So in the layer, how do you split your application in such a way where you have a set of collaborating services, right? So that is essentially the microservices are, right? So we may be doing these a lot in terms of different ways. So the question is, how do we, or what are the common characteristics if you see of one microservice architecture, right? So there are a lot of characteristics. So I'm going to group a few of them here, right? So based on these characteristics, you know that you have the right path towards microservices when you solve that particular business problem. Right. The number one thing that you should take care is it's around it's organized around business capabilities. Right. So you have no particular product which pays the same technical stack. That does not mean that both can be in the same service. It's more about the business needs. So if you see that the ordering part of the shipping part of the e-commerce product that might be handled by one particular team, right? So that they are the one responsible for that particular capability. So that's why that goes as a one service, right? So this is more organized around business capability. And so all the services have independent governance, technical stack, and deployment. That's something that we have already discussed. So that's the key characteristics of microservices. So another set would be of on interfaces. So these are consumer person interfaces. So what does it mean is that when you create a service, you always think of who's the consumer of my service and you try to cater that way, right? So that when you consume a particular data, you don't have to do a lot of operation on that. It's readily available for you. So that's the intention of every service that would be. You always keep that as the first class citizen when you create a particular service. And the smart endpoints and verified. So you do not do a lot of processing when the data is established, right? So if you see something like an ESB or something, technologies like that, there are a lot of data processing that happens. You transfer the data from one format to a different format, right? Whereas with the microservices, the data is really flat. You do not do those kind of transformation when the data is traveling. And mostly these are based on HTTP and REST based. So even there is nothing, you just get the data as it is for the client server entity. So that's another key characteristics. So the last one is improve the fault isolation and eventual consistency of time. So one of the byproducts when you have multiple distributed data sources is obviously that you cannot keep in sync of all these particular data in a different database. So you may have a particular e-commerce product where you maintain stock somewhere and you keep ordering somewhere. It might happen that occasionally there may be in a given situation where you have got an order or it's not really easy, right? You cannot really reduce the quantity one by one, whereas the data might be completely stored in different. So you need to handle or you need to better suit your application architecture to kind of suit that kind of scenario. That is where a lot of trade-offs also comes, whether you need to decide whether what is the best way to process or proceed with the architecture, but it's for me, what benefits are there and what drawbacks are I should face. Right? So also for the fault isolation, there will be separate sections in the application where you want to improve that fault isolation. Obviously, that you need to recover from the error, or you cannot afford to have any exceptions or any errors where you want to give that experience to user. Whereas some other section might be okay. So when somebody is reading the review, one of the reviews is not really turned up, it's okay, whereas you want to make sure that 100% effort will be put on the audit to be successful. So these are some of the common characteristics of microservices. So yeah, so that is very quick kind of introduction. Thank you. If you have any questions, yeah, sure. Next.
We say that the data is not consistent and it will be consistent eventually.
Yeah.
Or some things like, let's say new user signs up, goes to let's say order page or some other page, where that is never a service. So for the data which I want to use, what are the strategies that we are using?
So you need to manage the. So imagine that you have, let's say, you run out of stock. You have like last 5 stocks you have in an e-commerce example. So you have to might have to kind of imagine that okay, this can go out any day. The application should have that understanding, and you should manage. So you see, sometimes it will allow you to kind of add to a cart, but just before you go to a shopping cart, finally you do a check whether it's really available or not, right? And then that time you say that okay, it's not available, it's sold out or something like that. So what you see is that you're not putting the load on the initial all the products. You are only putting the load on the one particular product, right? So how you kind of handle that situation is what makes sense. Is what is you take care.
Any recommended strategies to do that?
So it depends on the business to business, right? So in this particular use case, this is what it is. But there might be some people say that it's not a good user experience, it should do the other way. So it's how the business demands, right? So there is no kind of general approach. But the thing is that this is a problem that's coming. How to solve it, there is no real, you have to understand that.
Thank you, Mohammed. Please give a round of applause.
Yeah, it's here now, so this is your last questions. So we have a
Good morning. Good morning. I'm not sure how well organized I am, but you know what I've noticed here in India in particular is there seems to be a lot of energy around Docker, which is great. I do a lot of talks on Docker, and there's a lot of energy around. There's a lot of energy around Kubernetes and around Mesos, which is really, really great. What I thought I would do real quick as kind of a pre-part of my talk is to discuss DCOS a bit, just to give you an idea of how it fits into the ecosystem. Just because this is, I don't know how universal this is. It seems like there's some misunderstanding about that. Because I'm not switch. But my goal is to talk a little bit about this, but what I want to do to illustrate things real quick is actually switch to this. And kind of this is, I hope, I expect that most people are kind of familiar with what you see on the diagram, that, you know, with the Unix platform, you have a kernel, you have Linux at the kernel level, and then we've had a lot of distributions. We have varying init starts or system D, init, whatever. That is the init system, and then you have an application that's running on top of that. So this is a standard model we're used to seeing. I think something that's really useful to understand about this is that as an Apache or MySQL or some kind of process living on this node, they are not really compiled against the kernel itself, but they are compiled natively to run on that platform or that architecture. Does that make sense? So if you were to compile some code against the kernel, you would most likely be writing a driver. And so there's a very distinct difference between writing a driver for an operating system and writing an application that's to run on that platform, right? So we think of, at Mesosphere, I guess I should start out by, 4 years ago, I was a part of a research group at Serverless, which was bought out by CenturyLink, which in the United States is the 3rd largest ISP. And it was our direction, our goal. We were told, where's the cloud going to be in 2 to 5 years, right? It's like, humans are particularly terrible at predicting the future. And when you talk about technology, we're even worse, right? Like that was a crazy goal. And I cannot understand or believe, looking back, how good we were. And I don't mean that in an arrogant or egotistical way, but somehow we nailed it. We had 3 technologies we thought were going to be a big deal. The first was Docker, which was at the time version 0.3 and 0.5 were the versions I started working on. So that the first bits landed in 2013 in January, and in March, April, May, we started really investigating, wow, this was looking pretty good. Now, containers have been around for a very long time prior to that, frankly. We can look at zones, we can look at LXCs that came out in 2009. So Docker really did some really interesting things. The second one was Apache Mesos. We're like, how are people not looking at this? This is really, really good. And the third was CoreOS. And out of those 3, kind of the wild card for me. I don't. It still has a good place. I think it has some good legs. You know, you have Ranch OS and a couple of other options. And frankly, it's hard to get a new operating system into an enterprise corporation because there's a lot of vetting process. It can take years before something is certified as being secure enough to be at an enterprise level. Okay, so then I went into Microservices. I was hired by that company because I really believe in that vision. And then let's come back to this picture. We see Mesos as the kernel. Now, I don't know of very many people or organizations that actually run a Linux kernel, the kernel alone. The value of Linux and the kernel is the fact that I put GNU tools on top of that, and I put a distribution around that. I want command line tools that allow me to interact in a useful way with that kernel. That's what I need as a human at least, right? It depends if you're running on this thing. So the way we see Mesos is it's that kernel. And it by itself is really amazing. It does some really cool things, but there could be some things on top of that where we can build some like GNU tools that enable you to be quicker, faster, and more mature in that space. And frankly, I would never talk, especially in a conference or a user group meeting, about anything but open source. I've been doing open source for a very long time. I wouldn't be talking product. That's just not me. I'm an engineer. So I'm really happy that a year ago we open source and released DCOS. So the full DCOS is available. We of course have an enterprise version, which is more geared around security and some advanced features, things like that, things we think we can sell into the enterprise. But it's a lot like Red Hat to a certain extent. They've done a really great job of being successful at an open source tool, which is available for everybody if you want access to it. But if you want certified releases and things of that nature, they provide a nice value. So we see Marathon as being the init system of the entire data center. And then just like an application running and it's not compiled with the kernel, it's just an app. It knows nothing about Mesos whatsoever. It's just a Rails app. It's just Redis. It's just Elasticsearch. It doesn't know anything about Mesos. If you were building something and compiling it against Mesos, then you would be building a driver, just like you would be in the Linux space. And if you're building a driver in the Mesos world, what that really means is you're building a framework. And the word framework is kind of a weird word. I don't know if I like it. But what it really is Mesos. I don't know, do people know the history of Mesos? Let me take a step back for a second. Google came up with something really interesting around 2008 and 9. Actually, they looked at their data center and it's like, wait, we do web search, that's our business, but I've got a lot of cycles that are always free. What if we could use that? That was the question. What if we could leverage every cycle of the data center? And they created something that we know today is the board, the Google board. It was top secret at the time, and even being top secret, they like to spread their stuff and show it off. And so they would go into academia and have them sign an NDA and say, hey, this is what we're doing, we can't talk about it. Well, I went to UC Berkeley, and Ben Hyman was at UC Berkeley. And he said, you know what, this was really amazing. The board is very platform and very Google specific. What if we were to make that generic? And we created, he is the originator of Apache Mesos. Apache Mesos essentially is an open source variation of the board. But it has a very significant difference. Where the board is very specific, Mesos is as generic as it can be, but it's also really dumb. The kernel is dumb. It has a lot of really neat features, but it has no intelligence. It doesn't know anything. It's a scheduler, it's an orchestrator, but it doesn't know how to do anything. It doesn't know what to do. It needs another scheduler to enforce the ideas, the logic of what's important within this cluster, right? The intelligence is always in the second level scheduler. So it's a two-level scheduler. A follow-on to that history, by the way, is Yahoo took a look at Mesos and said, well, it's not made here, and it's not written in Java, so let's review this, and they created Yarn. So Yarn has some history as well, which is yet another resource negotiator, right? That's what Yarn is. And Yarn is not a two-level schedule. It's very specific, monolithic, and it's very specific to most data analytical space. So when we say we're going to create a driver for Mesos, what we mean is a second-level scheduler, and there's a couple of options that we can talk about, which leads kind of into the talk road. So and then we get to something a little bit more mature, which is what we see a lot of organizations move to. Now the challenge that we have is if you are starting to create a scheduler, something that knows how to orchestrate something. Before I dive into this, let me walk through an example of what I mean. And when would you create your own schedule? That might be a really good question, right? So Marathon exists. Its purpose is to have long-running processes. It will start an app up, and if it were to die, it will start it up again somewhere else. It will just keep it running. It's its job. There's a lot of people who like Mesos, and they like Kafka, and then they would manually start up Kafka with Marathon, and that's possible. HDFS, I am one of the I don't know if anybody else talked about this. This is what I think is the right way to go. So I probably ran out of most of my time. I'm going to talk for a second about DCOS SDK. On the Mesosphere team, we're like, hey, it's too hard to create a service, to create a driver, if you will, in Mesos, to create a framework that schedules things. And we began to realize there's a lot of commonality with things that you would be interested in doing. So we created an SDK to simplify that, and it's mostly written in Java. It's focused on Java. When I was one of the early authors of this, I actually had two goals in mind. One was to have a low-level API where an advanced user could do anything they wanted, which is simplify things. The other would be a high-level API where, as long as I was following the general accepted things to do, like the 80%, magic would happen for you, right? I like the idea that the right thing happens for me in most cases. I want a solution for that. It has evolved further than that since I've left this team. And now we've created something where literally you can describe something in a YAML, and it will just create a service for you, which is pretty crazy stuff. So that's kind of the problem that we're trying to solve, is that we should make it simple. You should question whether you need a scheduler in the first place. There's Marathon, there's Chronos, there's a couple of schedulers that exist. But just like I described with HDFS, there are times when you're like, there's enough rules here for orchestration, and there's enough rules here for managing how we do recovery, that I need to build something custom. Another side thought, by the way, just because it's interesting. Two Sigma's, the second largest hedge fund in the world, they were probably the first customer of DCOS, and they do something really interesting. It's a hedge fund. So what they do is they have a bunch of agents that are launching in an analytical cloud, essentially. It's all analytics for them. They will launch algorithms, which they are going to try to make money off of. And depending on how much financial benefit you've earned the company based on your algorithm will determine your future of how much of the cluster you get. So it's a true merit-based system. We can actually change how much execution and resource time you get based on other factors, right? They build a really interesting service there. So, okay, to give you an idea, and this comes from our own work, right? We took an application and we built it, a scheduler, and it was tens of thousands of lines of code. You built everything on your own, essentially. This is a very common thing to see. This is what we see with HDFS, and with the Kafka, and with the Cassandra, which we've written all those frameworks. We've also helped others write theirs. We created kind of the initial start of the SDK is we created a set of libraries that just simplified things. We got to about 1,000 lines of code, which is still really nice. We now have, for at least simple examples, the ability to do 100 lines of code in order to have scheduling, which is a pretty big. And this is what it looks like. If we were going to create this, so if you wanted to gain access to this, you would go to DCOS Commons. Go to Apache, go to GitHub, Mesosphere, DCOS Commons. That will be the access to all of the code in Commons. Included in Commons is the SDK. You'll actually find this code example there. It's obviously simple. It's just the hello world. But we have a name for it. We have a principle for it. Why would we do that? Mesos is actually getting relatively complicated for many people. It's some interesting concepts. One of the significant advantages so far that Mesos has over Kubernetes is that I think we manage maintenance better. And I don't know if there's an option for Kubernetes. The other is persistent volumes. But when you have a persistent volume, what it says is if I have Cassandra and I launch a process for Cassandra on a node, I want to be able to reserve resources and guarantee them for that service. Because if it were to die, I want to be able to come in. If you had Kafka or Cassandra and Spark in the same cluster, right? Spark might be greedy. If Cassandra died, Spark might go, oh, there's space, I'll take it. And so we got to stop that. We got to figure out a way to manage that. So that is called reservations within the cluster. And that is managed by the principal. So the principal, fine, what's that?
Just a quick question. Behind the scenes, does it do a marathon?
Yeah, great question. So the init system in DCOS is Marathon. When we're talking about this right here, this is not Marathon, this doesn't go to Marathon directly. This gets packaged into a bundle that then Marathon will use. So, yeah. And that's another really good point. When I launch something, you know what, I don't know if people in here have actually seen these. Let's see if it came up. Yeah. All right, let's use my cluster I just created in Singapore. All right. Let's see here. So I'm just logging in for the very first time. I've never been on this cluster yet. So what it looks like is I have a set of command line tools, and I say, hey, tell me what my cluster looks like. So I ask for nodes, right? But here it gets really, really interesting, right? I can say EC2 service and see what services are available. I can see Marathon and Metronome are the default, Marathon being long running and Metronome being a project type stuff. But what's really cool is when you have things launching into a cluster, you may not know where they land. And in fact, this is one of the hard parts for ops teams. They're like, I need to know what IP address to go to. Like, what if I have to debug this? What's the universal tool for debugging for ops teams? I need to know where to tail things, right? The logs, right? If I gotta tail something, I gotta know where to go to tail, right? That's a really interesting concept. What if the tooling could do it for you, right? So what if I'm suspecting Marathon of doing something wrong and I'm questioning it, right? What are my options? Well, one option is I can say EC2 service log, log follow Marathon. This is the very first time I've done it, so I have some SSP exchange things I gotta do. But what you're seeing now is I'm looking, this is running on my laptop, this is on my Mac. It is streaming to Singapore, to the region, the Singapore region with Amazon, AWS, to the DCOS cluster, found a location of where Marathon is now streaming the log directly to me right here. Right? I don't know where it's running, why do I care? Right? What's really cool, and it would take me a few minutes to set up, but if I did something like go into, let's see what it's saying. Yeah, the first time I've been here, so take me a second. All right, so I'm going to go to services. Now, again, I just want to emphasize that what we're seeing underneath the covers is Mesos. But this is Mesos with the GNU wrappers on top of it, right? In other words, like some really fancy tools that make things more useful. I'm going to go in here and create a thing asleep. I'm going to sleep for some crazy amount of time. Here's a bug I recorded on Jira already, but I'm going to switch that to this and say run. Say run. And that service is going to be created for us. Couple of thoughts. You know what? Let's just go ahead out here and say I want you to scale to 3. So now I'm going to come out here and say EC2 task. And I'll see that I have a sleep application with 3 different tasks running in the Mesos cluster system. What's really, really interesting is I can also say EC2 task log sleep. And what do we get? I get the standard out for all 3 tasks at the same time. I can say follow on this app and see a stream of follows for all 3 tasks at the same time just streaming to me, right? Or I can go, that's a lot of information. And I can say, okay, I want task, and this is the full ID, this is the one task, and I can then switch this out for log to just that. So now I get 1 instead of all 3. Right? I have tooling now that enables me to not know where anything's running in the cluster. Right? All based on Mesos at its core. Right? That's what we're seeing as the future. That's what I see changing. That's why I get so confused. Everybody's still in this statically partitioned world. And I don't understand why people are still doing that. I don't understand it at all. Clearly I've drank the Kool-Aid. Right? I get it. Any questions with what I've showed you? Because I'm obviously just all over the place at this point. Yeah.
What's the difference between Marathon and
Oh, good.
Marathon and Metronome.
Okay. So So I hesitate only for a second because I'm going to start with just the Mesos ecosystem, right? The Mesos ecosystem, Apache Mesos. In the Apache Mesos ecosystem, there's a number of schedulers out there. There are two that dominate long-running processes. By long-running, we mean start this and always keep it running. It's my normal operation. And I want some controls over it. Like I might have 3 of them running, and at some point I might come in and say, well, I need a 4th or a 5th. I want the ability to scale easily, right? In that space of Mesos, we have Marathon and we have Aurora. Aurora is the tool that Twitter has built, and some people like it. Marathon is the tool that the co-founders of Mesosphere have built, and that's our preference, of course, as well. If we go to the DCOS world, Marathon is our init system. It's the long-running processes, but we also need something for batch or like crumbs. At 5 a.m. in the morning, I want this job to run. And it's not expected to be long-running. It's expected to be a short-running job. That's what metronome is. I also hesitate a little bit because of this reason. Chronos used to be the solution and can be confusing to people as where did metronome come from. We have a lot of redundancy between, there's a lot of code weakness in Chronos, if I were to be transparent. It's known that we want to do something with that. Internal to our Marathon team, we're like, well, there's a lot of things here. The guts of it knows how to interact with Mesos, and it's kind of a different module that schedules long running or not. So what if we use the Marathon libraries, the code in Marathon, and put a short run scheduler on top of that instead? That became metronome. So that's how that became what it is. And there's been a lot of internal discussion which has not been resolved yet, where we're like, you know what, we should just take that and put it in Marathon itself. And Marathon then would have long-running processes and jobs in one tool, right? And I think that's what we'll do. It's not clear, but we have to do something with metronome. We have to do something. 5 minutes.
And one last question.
You'll find, by the way, that I'm insanely transparent. I hope that helps my company, but I don't know. I just, you know what I mean? I love what we do. I love where we're going, but I'm not gonna. I'm gonna tell you the truth. So.
There is a staging process in Mesosphere, but do you have same feature in DCOS?
Staging, what do you mean?
Staging an app, because if you do an app...
Everything we do with DCOS, the use of the kernel of Mesos, and we leverage everything in Mesos. In fact, there's been a lot of things that we've been wanting to do that we've pushed into the Mesos world, but I don't know if you know how hard the Apache foundation is. It can easily be viewed that Mesosphere controls Mesos. And we have the majority of committers, and frankly, Ben Hyman's the chairman of the PMC. But everything's community and committee driven on Mesos. So we have to go through the same process. We have a lot of influence, but we don't control it necessarily. And that's part of the reason why Marathon is under the Apache license, but it's not under the Apache Foundation, which is a different thing. We do not want at this time to have to go through that process. It'll slow everything down, and we need to run at this point, if that makes sense. So I think at some point we might, if it makes sense to us, move that into the foundation, but right now it'll slow everything down, and we can't do it. But to your question, staging and how we manage the staging of things, it's all Mesos driven, and we do all the same stuff. And frankly, I showed you the nice UI. We put a pretty UI on this up here, where we have like a repository. In fact, what can I install on this? Package, search. Notice I'm at the command line, right? See if it comes back to me. It's probably too much information. But I can say DCOS package install. Let's install Cassandra. Look, I got stop right. Again. It's going to say, hey, you need this much in your cluster. Are you cool with that? I'm going to say, yeah, sure, good. And frankly, if you don't like command lines, if you have a world where you like GUIs, we can come in here to the universe, go into packages. I can say listing of packages. So when we talk about DCOS SDK, part of it is how do I land this in the universe so that somebody can just look at it and go, yeah, I want that. Like, I want to be able, you're going to hear later on, deal with Jenkins. Great. You want to install it? You just say, Install this package for me. The question becomes, do you want advanced settings or defaults? Do I want to be able to control some things, or do I just want whatever the default is? Okay, go ahead and install that for me. And what we see is a staging of that process going on right out there right now. Cassandra's being deployed, Jenkins is being deployed. But at the core, if I were to come to the UI, I could switch this out and say, you know what? I'd really rather be working at the Mesos layer. And so this is all the stuff that's happening underneath. This is Mesos underneath. I have full access to Mesos. So any of the tooling, if I built up a bunch of RESTful tools to integrate with Mesos, it all works here. If you have tooling to manage the scaling of things with Marathon, it all works here. It's just a nice GNU tools on top of a kernel. And I can still get to the kernel, right? That's important. Our whole focus, if you look at what we're doing with Mesosphere, is any kind of cool stuff you see on Amazon is neat. It's really fantastic stuff. We're not against it. We just don't want people to have to be locked into it. So we want to be able to provide all of those services, whether it's a Lambda architecture, whether it's serverless, we want to be able to provide all those things on any cloud, so that you're not locked into anything. So that's our goal. Sounds like I'm out of time. So if you have other questions, I'll hang around for a little while. Thanks.
All right, thanks again. Thanks for taking time off of your supposed to be your Azure and coming here to join us. Next up, we have we have an introduction to microservices. Next up, we have an introduction to serverless. Please welcome Vishnu Vishnu.
Hello. Yeah. Yeah. Good morning, everyone. So I am Vishnu Mishra, working in a startup called Enterprise Software. So, and today I am going to speak about serverless. So, what is the serverless? And let's see, and obviously it's my first talk, so please, if something went wrong, just please help me. That's all. Yeah.
We're gonna code for you.
We're there.
Yeah. Obviously. So yeah, let's start. So where does our code run? So where does our code run? First is previously we have mainframe, now it's a virtual machine. So virtual machine where you can just suppose virtual machine and your run code. Now containers came, so it's a like OS level virtualization. So where you have multiple containers which will run on same OS using same kernel. Now it can run on client side like your mobile application, web application, Android iOS, and now next phase came platform as a service. So where the provider of the service like Amazon and other AWS and Microsoft Azure, and I think they will provide you the hardware as well as a software application which runtime you need to run that. So
And now next is backend as a service. So in backend as a service, so what will you will get? So backend as a service, you have bunch of services, microservices you will run, and your mobile application or front-end application will interact with that using API as API, and you will get response. So you need to just manage different services, but yeah, obviously there are some problems there. So in backend as a service, okay. So yeah, now let's go to function as a service. So function as a service, it's a small independent function which will you will host, and it is also called as a nano service, you can say, and which is a part of which is a serverless, means you don't exactly need to host a server for that. You just write your code and you just need to deploy. So next is serverless computing, also known as function as a service or nano service. So deploy, it's a thing like you just need to write your logic, business logic, and just need to deploy. You don't need to worry about maintaining server, managing infrastructure, and everything. So it all will be provided to you by the providers. So deploy your application as independent function that responds to an event or REST API. You will get charged only the resource you will using and what time it will run, and it will scale automatic. You don't need to manually just set, yeah, you don't need to scale. It will automatically scale for you. So there are many providers which will provide these services for serverless. AWS Lambda is one, Microsoft, Azure function are there, and Google Cloud function are there, and IBM OpenShift is there. So these are some providers. Now function as a service, if we say about that, so backend code without explicit server and server app. You don't need to write any server, manage any server. You just need to write code, and now you can choose like where you want to run, like Node.js 4.6.2 or Python 2.7 or 3.0. You just need to select which runtime you need, and then you can just write your code and deploy, and it will run. So usually small functions, and now these many the cloud company, they are using many. You can use many languages: C Sharp, Python, Node.js, Java, and F Sharp. There are some IBM and Microsoft. They are supporting many languages, and although Google Cloud is only recently supporting only one language, JavaScript, Node.js only, but yeah, resource allocated when you need it and surrender after execution. So when you need resource, it will provide you resource. Once your execution is finished, it will surrender that resources. So horizontal scaling is automatic and elastic and managed by provider. You don't need to worry about that. Open source and hybrid alternatives. Obviously, there are some GUI tools which you can use. Consoles are there, but there are some many open source tools are there. Serverless is one of them. Serverless framework which you can use, and there are other framework which you can use to manage your application, serverless application. So yeah, so what will happen in a study? It's found that the 20% of the time in development they are spending on network, they are spending on infrastructure. So by serverless, it will reduce that time to 5 to 10%. So now you have more time to market and sell. So there are many. Now you will get extra time to your development and those things. So it will improve development productivity. Focus on business logic. You need to just focus on business and just write code and just it will deploy. Can work with source controller and CI. You can use GitHub and Bitbucket. You can integrate with them. Local dev tooling are including. So obviously there are some providers which they are not providing local dev tool, but some of them they started. So serverless framework is that one which will provide you with locally testing, and you can use that wide range of triggers and templates are available. So open source, there are many templates and triggers are available. AWS Lambda, which have so recent even many triggers are available for every event. So once if you are uploading any image to S3 bucket, so when once an image will come to S3 event, so you can just take and you can create multiple event images from them and again show to S3 bucket. So this kind of thing you can do, and you will get charged only the when your function will execute and how much memory it will take. So it's like 120 MB for 8 seconds if it will take, then it's going to be 1 GB per second, 1 GB second. So and they will charge all you on basis of the GB second. So, and green computing. This is the new thing is green computing. Like if you have EC2 instance and you are using, but if you there are some idle time when that EC2 instance is not getting used. For that time, but cloud provider, service provider, they cannot allocate that resource to anyone else. But if you are using serverless, only when you are using, they will provide that service to you. After that, they allocate that memory, that space, that container to anyone else. So they can use. So in this manner, it will reduce those things. And security. Security is another issue, another thing. So there are many things. Even if it's a serverless, it will run for a few seconds. So if anybody will find some way to hack things, to log into your system, still he have means they have only some few seconds to do anything because it's not running a last running process, long running process. You have some few seconds to hand, so obviously it will include security, and there are other thing by using which you can improve securities. So obviously there is nothing everything good with that. If there are multiple servers, then yeah, there are multiple functions. Then obviously there are some network latency and other issues are there. So execution environment is limited. So currently like Google Cloud is only providing Node.js, JavaScript, but AWS recently they started with C# also. They have some limited only environment. For further, they are developing and yeah, time, memory, and storage. So they have the function should they have some limited time to run your function like 5 minutes for AWS Lambda, and they have some certain memory which you can allocate for that function. It's not infinite as much as you want. You can't take that much. And storage. So there are some limited storage for local variable, local entity, like 5 MB for AWS Lambda. So actually, we are using AWS. So I know about AWS Lambda. So that's okay. Network throttling is there. So sometimes it will take time and it will latency is there. Startup latency. So once your function will start and execute, it's fine. But for new function call, it will take time to warm up that container and then it will execute and then it will surrender that. So it have some latency, but obviously there are some ways around which you can use, like calling that function every 5 seconds. Just have so yeah, this will keep that warm. So you can subsequent call will be faster. So all code must be stateless, so there is no guarantee if you are putting any state there, you will get back those state. Loss of server level optimization. Server is not in your hand control, so you cannot do optimize. You can't optimize that. But yeah, obviously those are already optimized by those, but yeah, further optimization is not possible. Yeah, testing is not straightforward, but there are other ways like locally running and those. Some framework they are developing day by day, so they are evolving, and yeah, some framework will provide you locally testing, but currently it's tedious. It's not straightforward. So if I compare with AWS, so there are two major providers of AWS, Lambda and Azure, and yeah, IBM is new, so I will mention that. Sorry. Yeah. So AWS Lambda will provide you some features, some environment like JavaScript, Node.js, Python, Java, and C#. And AWS Lambda have bunch of other languages also support for PHP, Bash, PowerShell, Bash. So these are even preview mode, but yeah, you can access that. And there is independent function in AWS Lambda, but Azure function, they are function group into app. If you need to create one app, then you will create multiple functions inside that app. So versioning is already in AWS Lambda will support multiple versions. So I'm not sure if now they started Azure also supporting multiple versioning, but yeah. So there are some limitations in AWS Lambda. You can use 5